Jai Hind viewers, we welcome you back to another panel discussion from MRO Digest Forums. We have got our panelists from our group today who are known figures in the MRO in the defense. We have with us Lieutenant General Dr. N.B. Singh, who served as the Director General of Corps of Electronics and Mechanical Engineers, Director General Information Systems, and was a founding member of the Armed Forces Tribunal, Jabalpur. He specializes in armored fighting vehicles and played a key role in the design and development of bulletproof vehicle Takshak, Arjun armored recovery vehicle, and made a significant contribution in the development of Dhanush gun system. He has undergone specialized training in Germany on off-highway vehicles and served in Moscow as a military attaché technical. We also have with us Lieutenant General Dr. Anil Kapoor, who served as the Director General Electronics and Mechanical Engineers and Director General Information Systems. He's a chartered engineer. He was awarded the Eminent Engineer Award 2020 by Institution of Engineers. He's a professor of practice at IIT Tirupati and also a board member in their Innovation Hub. He writes and speaks on emerging technologies like C7, ISR, and AI in many publications and platforms. And we have also with us Brigadier YVR Vijay, who served in the Corps of Electronics and Mechanical Engineers, where he was Chief Managing Director of an Army-based workshop. After retirement from the Army, he entered the renewable energy sector, where he was the COO of Enercon India Limited and subsequently the COO of Suzlon Global Services Limited. He is now a subject matter consultant on renewable energy to Boston Consultancy Group, McKinsey, GLG, GuidePoint, Alpha Sites, and Third Bridge. The panel discussion we have today is on the next generation MRO or NextGen MRO. General N.B. sir, may I start with you with the first question? May we have your opinion whether there is a pressing need for next-gen MRO in the military? And why aren't the existing practices adequate from the operational effectiveness angle? NB, sir?
No, you see, we all are aware that MRO infrastructure and MRO resources form a very important and integral part of any modern and large military. Unfortunately, in our context, because of the past 30-35 years of experience in low-intensity conflicts, adequate resources were not plowed in this direction, because everyone expected that, wars of classical wars, the days are gone, and it is now the age of all kind of asymmetric warfare and things like that. But we all know that MRO resources are basically being used by most militaries with a specific operational objective, and that is to repair and reset complex weapon platforms and return them to the warfighter in a fighting fit condition, which is generally in the present day vocabulary, it is known as like new condition. So this is the aim. And what we have seen, another dimension of modern warfare, is the huge amount of attrition, destruction of men and material, which has taken place in this conflict in East Europe, where on one side, Ukraine, lost most of its hardware in the first few weeks of the war, and the other power also, who's supposed to be a big industrial power as far as military technology is concerned, that power also came to a stage where they were finding it very difficult to replenish daily losses, to the extent they started thinking of rejuvenating their old platforms like the T-34, T-38s and all that. Now, whether that has happened or not, we don't know. We will come to know maybe this year. But the point is that today's warfare is now becoming an industrial scale warfare. It's a warfare where you need MRO resources to rejuvenate and regenerate. And you also need enough industrial resources to support the war effort by quickly creating that industrial surge and sending out more and more weapon platforms to the front line. So that is the context which I am trying to just revise. And you know that today in most armies, the biggest problem is that particularly the armies from where we used to draw our lessons, the Western army, primarily the British Army. Over the last 2-3 decades, we found that there was a gradual reduction in the total size. They came down to less than 1 lakh with hardly any weapon platforms. And therefore, for them, it was a kind of that yes, we keep it lean and mean, and we go about paying them well and keep a standing army. And they possibly knew that there was no requirement of their increasing the size because the kind of threats they were envisaging was lost. And therefore, they continued using those old practices, which we also use, and that is good old, the scheduled maintenance based on a certain periodicity, whether it is 6 monthly, annual, and thereafter based on kilometerage and periods, the time. So they all were happy following it, and we also continued to follow it. But now I feel that with in our context, especially, whether the others do it or not, most of them are not inclined to do it because, see, even in the US Army, the first project to commission to start this kind of a use of, predictive and prescriptive maintenance started off in 1996. But then it got restricted to only the gas turbine engine, and thereafter it was not taken forward. In our context, now that we have a large number of platforms deployed in the open, in a very, very difficult and challenging terrain, we have to know that the effects of age, usage, and deployment will kick in. And therefore, it is very important that at any instant of time to know as to what is my residual useful life. That is the battle endurance. So for any platform which we have deployed, we can't just say that, okay, it went there in a class 1 condition, and so therefore if it's not moving, and it will remain in a class 1 condition. No, because of, even if it's not being used, because of the terrain where it has been deployed, large scale deterioration will take place. So to monitor the equipment capability, to analyze as to what is my residual useful life left, I need a kind of analytic tool. And wherever this kind of analysis is required, you have to go in for what is known as a kind of a model-based maintenance. And it is here that the modern maintenance practices can become very useful. You create a model of an ideal method of wear and tear. And when you compare the actual wear and tear, which is taking place at an accelerated rate, at a fast rate, you compare the deviations and then take a call as to what needs to be done. Now, this is not a very difficult thing, very big thing, because onboarding of sensors is now there in a big way in most, most platforms in the civil, complex platforms like the mining and earth moving and all, high wall miners and all, which are used in the coal mines. They have a whole lot of them, and they are all networked at a central control room. The information flows through telemetry. It is monitored by a group of people, and whatever intervention is needed is from there it is passed on to the maintainers at site, and they carry out those interventions. It is being done there. Uh, for the military, I feel, at least in our context, whatever we have deployed at the LAC, we should look at doing this. Only problem is the money, because if you see whatever money we are spending this year, we plan to spend more than 1,90,000 crores on the revenue side, which is around a 5.5% increase over the budgetary estimates of last year. Now, when you compare this whole revenue budget and you compare it with the US Army's budget only for the base maintenance depots, it is another 60,000 crores more than this. So the US Army's annual budget for last year was 2.5 lakh crores. Ours is 1.96 lakh crores, revenue budget for the entire army. So, finding the resources to do this exercise on such a massive scale is the problem. Otherwise, yes, these practices which have already come into the manufacturing industry, all these new technologies, like 3D printing and and robotics and drones and things like that, they certainly have a scope in our context. As we proceed forward in this discussion today, I will highlight some of them as to how they can be utilized.
Thank you very much for that, sir. You mentioned about sensors, and I know General Kapoor has done a lot of work, and he's talked about and written about that in a big way. Especially also he has talked about how it can be used for legacy equipment. So, General Kapoor, my next question is to you. What are the key drivers of NextGen MRO? General Kapoor, please.
Thank you, sir. I think when we look at drivers of MRO, with the change in times, technology is coming to the forefront. We find everywhere technology disrupting way of life. And MRO is no different. So today, with the sensors and IoT technologies having come up, which I call the semiconductor part, and artificial intelligence and data analytics, especially the big data analytics coming up, which I call the software part. So really speaking, semiconductors and softwares have actually redefined the technology that can be embedded at the design stage itself for enabling MRO as a embedded system. And this gets me to what General NB alluded to as well, condition monitoring system. So actually, the whole system is becoming condition monitoring, which I actually call humanizing asset, which I spoke on your forum some time back about. So really, therefore, the first driver is technology, and it will remain so. When we talk of technology, few more additives that are coming in. One is robotics, which is coming up in a big way. Robo welding, orthogonal robo welding for smart manufacturing has come up in a very, very big way today. Most of the industries are following it to do high quality welding. Then we got 3D printing, which is again a recent development over the last decade, where not only manufacturing, it also facilitates a lot of MRO activities. More importantly, when you have certain assemblies and components which may go obsolete, and OEM may not find it viable to continue its production, I think 3D printing comes in a very big way to help you salvage the situation from an MRO perspective. So that is one big vertical. The second big vertical I'd like to talk about is big data platform. Unlike previous times, today big data platforms are coming up, and the humongous amount of data that is getting telemetered today for health check of every assembly, sub-assembly, system, subsystem, even baby components, critical baby components, actually gets analyzed to give a kind of a predictive prescriptive analysis. So it tells you which assembly is safe and in a green zone, which is the amber zone, and which is the red zone, which needs to be on the lookup display of MRO expert to take the right call at the right time for creating if I may say, a seamless operation. That means only the downtime will match the logistic pause whenever it is planned, so that the show goes on. And that is a new trend as a driver in MRO, using information systems for MRO. The third, I would say, continues to be skilled labor. I would have put it as the first one, but the skilled workforce will always remain important. And I think with the way technology is becoming more and more complex and miniaturization is setting in, there is a need to actually look at the skilled manpower from the point of view of building or designing MRO into the equipment itself, so that it becomes easy, and lending the system to, should I say, a lesser engineering support, system engineering support complexity, so that a user can maintain it himself. And when I say this, it is repair by replacement forward, and maybe all the other things can happen rearward. So skilled workforce will remain important, and more importantly, they need to be certified, especially when you look at some of these trades, and maybe I'll allude to it a little later again, on certification for skilled workforce, depending on the expertise. In the army, also, we are now looking at, even welders and others getting certified beyond grade 1, grade 2, and grade 3s, to look at his competency levels. And I think same would go for many other trades that we look at. The fourth driver, to my mind, is the cost. I think this is one of the biggest drivers, because when we look at legacy systems, we have to look at the cost of maintaining it over a period of time versus the cost of upgrading it in terms of technology, and what dividends come out of it. While cost will remain important, I think it makes perfect sense, both in the army and in the CV street, to build in as much technology as you can into the systems, because it helps you in the long run in life cycle sustenance support, which is the crux. Because when we look at the whole life cycle, it spans 15 years at least when we look at civil equipment, and maybe 40 years and more when we look at military equipment. So why not build in technology and derive the benefit? More importantly, when you are getting operationally oriented, if the equipment talks to you and tells you when to do what, I think the confidence banding of commanders in mission reliability improves, which is the crux of the whole game. The fifth driver, I think, is cyber. Now, when we look at a lot of data, and in fact, I call it cybertronics, because when you look at information systems and when you look at communication systems, they are fairly susceptible to interventions, to countermeasures, and therefore, what we will need to build in is cyber safe and electronic safe systems. And therefore, this today becomes a driver of MRO itself, because any information flow, any data flow that has to happen has to be in a very secured manner. And the last driver I put it is green energies or renewable energies. Today, the energy spectrum is changing in a big way, and a lot of hybrid systems are coming up. Even the electronic systems today, the current generation are going to come up with inbuilt solar system, so that you charge it by day and use it by night. Now, the batteries which are there actually would be, you don't need much of electricity, because solar power is available and electric may be a backup available to you. And therefore, the complexity, when we look at the mechanical systems, it could be hydrogen with electric, it could be petrol with electric, it could be diesel with electric, but hybrid for sure. And with biomass coming in and other forms of green energies kicking in, I think energy is going to be, and therefore hybrid systems are going to need a different kind of a treatment. And that will become another driver, which will also become a supply chain driver. So that way, in MRO, we will have a supply chain driver defined by energy. So this is some of the new landscape which one is looking at. I mean, the conventional drivers and pillars that we used to speak of do remain relevant. They will never become irrelevant, whether it is infrastructure, whether it is tools, test equipment, and all that we've been talking in the past about. But I think the new drivers are kicking in, which need to be built into our MRO setups to derive maximum benefit and enhance our next-gen MRO abilities. Thank you.
Thank you, Anil, for that. In fact, Brigadier Vijay, when Anil Kapoor was giving his views, I was again and again reminded of the tremendous work you did as a pioneer in data being used, live data being used when you were CEO of companies to actually bring the effectiveness of MRO to a level where even the companies were turned around. So my question to you is, what do you think, Brigadier Vijay, are the latest top 10 in MRO techniques? Brigadier Vijay, please.
Basically, sir, if one has to see what is it that makes good MRO, is when the MRO organization has accurate knowledge of the health of the equipment that he is maintaining. It is only then that he can predict how this equipment will perform when it is required. He can then predict what is the residual life of that equipment. He can then predict what is the type of inventory that is required to support an equipment based on the condition of its health. Next, when an equipment is under use, then an MRO organization should be able to monitor, is it performing as per accepted standards? Now, if we have to look 25 years back or 20 years back, when there was not so much IT, etc., a lot of this was book entries. The vehicles will come into the repair floor, then there'll be a low-tech person who will go capture what is wrong with it. And that is the data that you're capturing. Then he'll say that I replaced the spares, and you know. Based on that, a lot of data, I mean, your inventory management systems got built up. But now, with the help of IT, with the help of sensors, there are so many new techniques which are coming in, which can enable MRO to become 10 times better. Now, basically what these latest techniques, the aim of them is get a better knowledge of the health of the fleet, reduce the downtime of the fleet, increase the residual life, that is the equipment lifespan, bring down costs, enhance the productivity of the whole machinery that you're doing, reduce labor requirement, and have better planning mostly. Now, some of the top MRO techniques, we have discussed it all, in fact, earlier also, and General Anil Kapoor covered a lot of them. At the top most, I would say, is to know the health of the fleet. For this, we have predictive maintenance. Now, predictive maintenance basically looks at capturing the data of the fleet digitally. So then it uses advanced analytics, sensor data to predict equipment failures. And based on this, you can schedule your maintenance before a breakdown occurs. Because nobody wants, in the modern day, to have the old method of fixed 6 monthly maintenance, 1 yearly maintenance, quarterly maintenance. You want to schedule your maintenance before a breakdown occurs. You want to minimize downtime and reduce your overall maintenance costs. So predictive maintenances rely on a variety of technologies, the IoT, analytics, big data, AI. All this data from the sensors are gathered, and then you develop your maintenance techniques. The next, very similar to this, is prognostics and health management. This integrates data analytics, AI, and determines what is the residual life of the critical components. So then if I know the residual life of critical components, I can start replacing them, plan my inventory management in such a way that I can do proactive maintenance planning. Then we have other technologies with AI. One of them is AR, augmented reality. Now, AR is being very actively used. In fact, when I was in Suzlon, we had late Colonel Vinay Gupta introduced AR for maintenance. So basically in this, when a person goes in to repair a critical equipment, he's carrying his laptop with him or his mobile where the app is running, and you can put an overlay on the critical part so that while you're repairing the thing, you can see what you're repairing. The instructions are coming up on one side, and it's an expert system which is giving you ideas on how to do it. So AR is being increasingly utilized to provide maintenance techniques with technicians with real-time hands-free access to information. You don't have to know it all here. While you're on the equipment, you've got your mobile or your laptop, which is continuously guiding you. This AR is used extensively in the aviation industry for aviation inspection, troubleshooting. It is used for industrial equipment maintenance. It's also being used now for automotive repairs. The latest, if one goes to these MG and MG factory here, MG repair center I visited recently here, you're seeing them coming in with the laptop, and he's getting live feed based on what he's seeing. Then 3D printing, this was covered by General Anil. It allows for rapid production of custom replacement parts. And it reduces lead times a lot. For example, when we were in 515, to get a prototype, it used to take us 5-6 months at times. Whereas with a combination of 3D scanners and 3D printers, you can reduce this to a week. And if you have good labs which do material testing, then you've got a force multiplier in place. So combination of 3D scanners, 3D printers with material testing labs is another modern MRO technique. Then in the big, large, critical parts, like, for example, your gearboxes, your bearings, and like when we work with very giant gearboxes, like 100 megawatt or 10 megawatt size gearboxes, like in the wind industry, is condition-based monitoring. You place your sensors in various critical places where you're getting a live feed of the data, and you are continuously monitoring the condition of the fleet. So you're using sensors, data analysis, and you can schedule your maintenance based on how it is performing. And sensors today can be a vibration sensor, temperature sensor, oil quality sensors, acoustic sensors. And from all these, you can get adequate data to know that my machine is performing as per requirement, or it needs to be looked at, or this part is gone. And you can do a lot of your planning, your scheduled maintenance planning, your breakdown maintenance planning, your inventory management also. Like we had put our CBMs on the main shaft, the intermediate shaft, as well as the high-speed shaft, as well as on all the gearbox, on the gears. So we were able to monitor, and I knew that if my gearbox fails in the rainy season, it will take me 2 months, 3 months to get a crane and replace it. So because of my CBM and predictive analytics, I was able to replace the gearboxes before the bad season came in. Doesn't matter if I lose a couple of months of life of the old gearbox, but I will not lose generation. So that is CBM. Then robotics and drones. This is coming up very fast. We have actively used drones for studying the health of the blades, so that you don't have to stop the blade and send somebody to inspect the blade. It's hardly a 2-minute halt, and the drone flies up and down and captures all the photos. We used to fly the drone along the power lines at all the junctions to find out loose connections, hot spots. And it improves your safety, efficiency, and speed in a high-risk environment a lot. Then, of course, IoT, we have spoken, all your sensors, etc., comes from IoT. Next is the use of IT. Today, this mobile that we have in our hands has got more information technology power than the best of computers in the world of 20 years back. And mobile applications are streamlining maintenance workflows to a huge amount. You can go in and do your 100, 200, 300 checkpoint scheduled maintenance with a mobile maintenance app, which is continuously guiding and capturing photographs. And the technician will have access to the work order, equipment history, documentation via a smartphone or a tablet. So it increases the productivity and communication that that technician has with his equipment and with the rest of the MRO organization. Because of all this, you can resort to a reliability-centered maintenance, which is another technique, where you study what is the potential of this equipment failing or a critical part failing, what is the potential impact of it, and schedule in your maintenance. Then remote monitoring and diagnostics. Today, you, with the help of sensors, mobiles, etc., you can maintain from a remote area as well, and AR especially. So these, I feel, are the 10 most new latest MRO techniques. Thank you.
Thank you, Brig Vijay, for giving those techniques. And so you have talked about AI also, and the aspect of readiness is something which General NB has always been urging everybody to work towards, because that's so important. And so, General NB, sir, in your view, to start with, how do you think artificial intelligence enabled MRO practice or practices should be architected to scale up battle readiness in the army? General NB, sir?
Yeah, I will actually, I'll give you actual applications where I feel that, it can be effectively utilized, because I still maintain that sensorization of our legacy fleet is neither feasible, from the finance angle, nor will we ever be able to convince the GS. I will not be able to convince them to, give you that kind of money to do this. So I feel it is more in the assessment portion that we will be able to use AI in a big way. And if we are able to give an op orientation to this work of ours, possibly, you may get the required funding. So first idea which comes to my mind is the contribution AI-enabled MRO services can make towards sustainment readiness, which is an integral part of strategic readiness. And strategic readiness, that today everyone is talking about that strategic autonomy, strategic assurance, strategic readiness to be able to face an enemy in a long drawn out war, which may last for 2 years, 3 years, 4 years. And for us, that is very much a possibility. So this is one area where we could use it. And the first thing I will recommend is a prediction of battle readiness, which means, to be able to configure a tool using AI, which should be in a position to predict the operational availability of a formation, of a regiment, of a fleet. And, convey to the commanders that, okay, here is Regiment A or Formation A or Combat Group A, and this is Combat Group Bravo. And this is what are their readiness level. This is the availability. This is what they are capable of doing. This is how fast they can run. This is how far they can jump. And now they can even go ahead and prescribe that, look, we will recommend that you go ahead and use Combat Group Alpha for this particular task. Now, if we can do that, I think possibly yes. And this is very much doable even without sensorization, because you know that our echelons capture a huge amount of data. And maybe some of it may fall outside the trend. If we do a trend analysis, we'll find some data may be outliers that you can neglect. But majority of the data, if it is analyzed properly, we will be able to come out with certain key performance indices or parameters, which can be the guideline in creating this algorithm to be able to predict battle readiness of a formation. The second is AI-enabled approach to designating platforms for medium reset and base reset. So this is again where a study of the MKBF, MRBF, MTBF will enable us to designate tanks whose reliability is suspect, to go in for MR and base reset first, and the others can then follow later. Third is strict configuration management. This is one place where it can be used. One place where I will certainly like to use it is headquarter technical group, where it should be used for the initial ESP planning. I think so much of data is available there. It is very easy for them to make an AI assistant which can take charge of this and readily come out with whatever packages you want, whether it is creation of ISG, or maintenance scale, overhaul scales, and things like that. So all this can be very easily done using AI, and I feel that a kind of a pilot can be started to execute this task. You must have recently heard about the how the latest tool Gemini. He was giving the example how it has been used by an old car, company like the Cars 24, something like that. How where you have given the condition of the car, the specifications of the car, and how it has been able to come out at the ideal value. He'd been able to assess the value of that particular car. So I think similar to that, we can use it in these places. Another idea which came to my mind is the networking of our. See, while we may not get enough funds to sensorize all these fighting platforms, but certainly we have the resources to do this by networking our FRTs which are there in the TBA of a strike core. You network them. We can also look at sensorizing them. We can also, look at acquiring a few commercial drones just for the proof of concept, and go about managing this whole activity in the manner that the drone goes and assesses the kind of damage which has taken place, and thereafter relays back and in the most appropriate. There is no point sending a mine casualty repair team to a place where to a particular casualty which basically needs a track tensioner to be replaced. So at least we can start these things at a very, very small pilot scale, and go ahead and expand it, because once you can prove this whole concept, possibly next stage will be that they will say, okay, come back and just do this for a combat group or a regiment of ours. So I think that is where we can use this. The limitation of the old system, we all know. I mean, it is somehow things are just moving on, but the old system does have severe limitations. Another area which of course is wishful thinking, but I think it is also doable later on, is a kind of a prescriptive, creation of I'll say a capability readiness analyzer, which actually analyzes the warfighting capability of a formation by having a combination of sensors and data mining and machine learning tools to be able to analyze. And let's say after the initial engagement, there are two regiments who participated and they both suffer huge amount of damage, which I said will be the trend now. Thereafter, the system is able to keep a track of how the replenishments are coming, whether they are new ones or whether they are being regenerated on site, and is able to prescribe that, okay, out of the two regiments, you can quickly bring up regiment A to a full squadron, 3 squadron level, and maintain the tempo of operations. So this, with the kind of damages which will take place, hundreds of platforms, not only it is one kind of a platform, but all kind of platforms. So you'll have AD missile systems somewhere, you will have guns somewhere, all getting damaged. So when huge amount of information will be flowing, it may become humanly impossible for humans to corral this huge amount of data and come out with some outputs. So it may be possible that is where we can use it and enable the operational commander during combat to take sound decisions to maintain the tempo of operations. And of course, in all kind of planning, as we said, whether you want to maintain schedule maintenance, where you want to control inventory, you want to do readiness-based sparing, reliability-centered maintenance, skilling, remote diagnostic, all these are the places where we should be in a position to use. But I feel that we must take a start, because nobody else will be interested in doing this kind of a work. It's for the core to take a start And let's start with smaller steps wherever we can do it.
Thank you very much. You've given a lot of ways forward. And so that actually brings up the question with so much of changes happening and so much possible, which is emerging, so many possibilities of technology, new technology emerging. So, General Kapoor, my question to you would be, what do you think will disrupt the MRO in the future? General Kapoor, please.
So actually, disruption has become a way of life. What we used to earlier call revolution in military affairs or revolution in civil affairs actually has become a disruption in military affairs and disruption everywhere. And that is because technology is giving you the luxury to disrupt, to change the way you think, the way you act, and the way you can create business models. So, to my mind, the first disruptor actually is ownership itself. And we see today there's a huge departure, not in India for the moment, but what I've seen it in America and some other countries where today even a car, you could lease it for 5 years, you could lease it for 1 year, you could lease it for 2 years, you could lease it for a couple of months, because the cost of ownership becomes high. Now, as an example, give you an example, somebody wants to really lease a Porsche for a month because he wants to get the feel of being owner of a Porsche. And therefore, the whole model revolves around a new ownership model. Now, looking at defense, as per se, today, lease is becoming a way of life. We've seen it happen even in the Ukraine-Russia war, where a lot of equipment is suddenly being provided. We're not sure whether it is on cost or it's on lease, but it appears to be on lease, because in a short time, you can't really create the kind of infrastructure that will be required in the last mile. We all know that our own DAP 2020 has brought in a new paradigm of lease. I think the first disruptor is the ownership itself. And therefore, when the ownership changes like this, the MRO model changes around it. Because then it's something like in the US, these shops have come up, you break, we fix. Now, this is a very unique model which I've seen, and I've seen it in some more places, wherein what I often say, skill is the new collar. They are not engineers. They are just those who are willing to learn, and they learn every possible piece of equipment, get OEM certified, and open their own MRO setup. Now, let me give you an example of this you break, we fix. Now, this is a shop which deals with cars. You break a car, come to it, it'll even Apple phones. And we have Apple stores where they do service, and you give it to them, and then they repair it and they call you maybe after some time. Here, he does it in front of you. And I've got my own mobile done, something that the Apple store said, sorry, we'll not be able to do this for you. This guy did it in $100. He reclaimed my mobile back to me. So the second disruptor is those who are willing to step out and take on certified MRO and take the, should I say, have the gumption to tackle technology as a life cycle sustenance support expert. I think this is, when we look at it from the Army perspective, I've seen in my own experience that somebody whom we called grade 3, actually, when well trained and well motivated, he could do repairs at par with grade 1s. And one, I'm sure all of us are from the same stock. We would have seen so many such examples in our careers where you pick up these people. So really, it is the spark in you. It is the will in you to do it. And therefore, if skill is the new collar, that's the new disruptor. So really, that is the second disruption I look at. The third disruption I look at is that today the world, given the technology thresholds, I often say is defined by 2 A's and 2 P's. Automation leading to autonomy, and precision and positioning. The whole template revolves around these 4 terms. And that is creating the new normal everywhere, and MRO is no different. I mean, General NB just alluded that, why remain in doubt? Use a drone to find out what is happening to a casualty, what is the nature of casualty, get as much gen as you can so that when you go there, you're totally prepared. It's a function of precision and positioning for a capability assessment that you do. And more importantly, YVR alluded to some live feeds that happen. And today we see that a lot of live feeds are there. I mean, you look at the share market, the way some time back we used to depend on the newspaper to see what is happening to the share market. Today, you can get it in real time, and therefore, real-time situational awareness and real-time common operating picture, which is so important in MRO and life cycle certain support, is afforded by technology, which is these precision, positioning, automation, and autonomy. I think that is the big disruptor in MRO. And how you can intelligently use it, how you can intelligently define your problems, how you can intelligently design your solutions is going to be the new normal. So this is going to disrupt in a very, very big way in times to come. I mean, we've already seen Elon Musk trying to put a chip in your brain to give you a new kind of brain wave, if I may say. I think these sparks are going to create the next disruption defined by technology. And the last, fourth driver to my mind, or disruptor to my mind, is regulatory mechanisms. I think the kind of waste that is getting generated, let's first look at the e-waste and the other waste that gets generated in MRO. How do you recycle it? How do you reuse it? How do you discard it? That's going to be, so very strict regulatory mechanisms are required. That will be the next disruption in terms of regulation. So there'll be regulation of waste. There'll be regulation on skills. I mean, everybody will not be allowed to do what unless he's certified to do it. The next is in terms of pollution standards. I mean, we've already seen it happen in our country. The CP standards today. I mean, when you were to buy earlier, when you used to buy even generator for the army, it could be any. But today, you have to make sure that it is CP norms qualified. And I think this regulatory mechanism is going to come up globally in a big way with global warming, climate change happening. You no longer can have the luxury of using huge pollutants or those which are not environmentally safe. So I think regulation will be the fourth disruptor. So if I may go over again, first is the ownership, and the cost of ownership is a disruptor. The second is skill, and as a new collar, which is going to be a big disruptor. You need not have an engineer really doing every job. It could be anybody who's willing to learn and do it. That will be the new normal, and who has the skill and aptitude to do it. The third is technology in terms of precision, positioning, automation, and autonomy. And the fourth one is a strict regulatory mechanism to control the MRO activities home to tomb, whether it is waste, whether it is certification of standards, infrastructure, pollution, energy levels, whatever. I mean, all this will need to be regulated very well in times to come. And therefore, I think this is the way this thing will evolve or should evolve globally, to my mind. Thank you.
Thank you very much, Anil, for giving out your views on this disruptors. And surely, I think all MRO organizations need to keep this in mind and be ready for that so that he can adapt to it. And so one of the disruptors which is emerging, I would say, is robotic processes. And so, Brigadier Vijay, with your vast experience, may I put this question to you? What is robotic process automation in MRO SCM? And how can this help with the inventory management in MRO SCM? Brigadier Vijay, please.
So today, if we have to see, let us say, talk of the core of EME itself. Let us say we have excellent technicians and they are empowered with knowledge, they are empowered with data, they are empowered with AI and the latest of predictive maintenance techniques, etc. How much would the quality of our output improve? I would say if you want X, it will improve by 0.25x. What is holding us back is, are we putting in the correct spare at the correct time when it is required? Is our inventory and supply chain management exactly tuned to when the equipment needs it? You might have the best of skill sets, but as General NB also brought out, if you're putting in a suspect hole or a suspect spare into that machine, you're building unreliability into the machine. So there's a great need for an MRO organization to actually have both together. The maintenance and the supply chain has to be together. Supply chain should never be treated as separate from the MRO process. That, in fact, is a great weakness I feel in the army today, and outside we don't see it in industry. The MRO organization has the supply chain. It's a captive supply chain, and supply chain it's a core task of the person who's leading that out. Now, coming back to the question you had is on robotic process automation. So basically a robo and a robotic process automation is using software in such a manner that you can emulate any repetitive human action which is low tech or which can easily be replaced by a digital process. So robotic process is a software technology that makes it easy to build, deploy, and manage software bots which emulate human actions interacting with the digital systems and software all across your MRO chain. So it's, in a layman's term, it's a combination of automation, a bit of computer vision, machine learning to automate the repetitive high volume tasks that are rule-based. And I'll give an example of how this whole RPA was used to improve the supply chain of Amazon. And then we'll look at a workshop also. So Amazon in its inventory management is using RPA bots for its order processing. It automatically processes incoming orders, validates the orders, updates its inventory levels. So it's got scanners, it has got robotic vision, and it reads off the data which is coming in, all without human intervention. So it speeds up the order fulfillment process. The RPA bots continuously monitor inventory levels across the various Amazon stores all over the world. They can send alerts, trigger reorder process, communicate with each other. You can do process automation, demand forecasting, inventory reconciliation. We don't need to do stock taking, shut down for a day or two, and then reconcile. It is a continuous live process because these software robots are carrying this out. Supplier communication. So the RPA with the ERP and the material management system of the ERP then automates communication with the suppliers. It sends purchase orders, it tracks deliveries, and updates inventory levels. So imagine a workshop that is maintaining a fleet of heavy equipment. Now these machines require regular maintenance to ensure they're operating efficiently and safely. And somehow slowly robotic process automation is introduced into this whole process. So as a use case, I can say maintenance scheduling and parts ordering, let us look at. So you can have your RPA robots programmed to collect data of equipment usage logs, the sensor data, maintenance schedules, so your data collection is good. You can do your RPAs can automatically generate maintenance schedules for each piece of machinery. It will consider the various factors for which it will pull out from the data books. How much time has the equipment run? What are the operating conditions? What is the manufacturer recommendation? Is it by kilometers? Is it by vintage? It can maintain the inventory of spare parts for these machines, checking the inventory levels. It can utilize the predictive maintenance data to identify components that are likely to fail and prioritize these for maintenances. It can generate work orders, and it can also, through the ERP MMS, generate the parts procurement process. So RPAs are basically will speed up your whole supply chain process and ensure that you are getting the correct material at the correct time. But finally, of course, it's that quality of the part should be as per specifications, reaching on the correct time. And you'll find that these two can revolutionize any MRO organization. One is the technician empowered with all these AI, IT, sensor data. And second is the correct part at the correct time, which RPA can help you in. Thank you, sir.
Thank you very much, Brigadier Vijay, for that answer. So, General NB sir, you are the patron of our group, and we are having these panel discussions, based on your guidance. May I request you to just sum up today's discussion, whatever you feel, Gen MD sir?
Yeah, certainly. We have heard this discussion today, and I think a lot of ideas have been uh, thrown forward for it is for our next generation to look at it and introduce these next generation MRO practices which we have talked about. But I feel that the areas where we certainly can look at it, one is how to decrease documentation in our workshops. Vijay has given those ideas there. I feel we can track this method of readiness based pairing, which I have been talking about for quite some time. It can be accelerated using AI, and I can only mention that in one of the cases for an aircraft where they tried this, uh, they ultimately came down from 4,000 parts. They ultimately came down to just about 300 plus parts, which needed to be, at any point of time to be present somewhere in the inventory chain, supply chain. So that will lead to a lot of savings. We should look at it as far as traceability of interventions is concerned, so that what we call as life cycle system readiness or life cycle systems management, we should be in a position to know as to from womb to tomb as to what exactly has been the kind of intervention which has been done to an equipment. That will give us an idea of how how much it has been tinkered with. Then maintainer to maintainer information sharing, we have talked about that. Digital twinning and things like that, these are areas where we should look at it. One place where certainly I feel it can be used is identification of fake parts, because now at least all suppliers of genuine equipment, or those who are OEM suppliers, we can have a system by means of which those parts can be identified, so that anything which is put into the complex weapon platform, see, normal vehicles and all is okay. You can put it there and possibly finish your journey and then look at getting an original part. But with weapon platforms, I think it is just not acceptable to do these things. Platform reviews, downtime analysis is other area. As I said, an ESP assistant is something which we should straight away look forward to. It will greatly help the work which is being done in headquarter TG, and possibly it will be more to the point and optimized. And finally, configuration management, of most of our systems. But till the time we are not able to put sensors on most legacy platforms, at least in this area of, planning maintenance, scheduling maintenance, managing inventory, skilling, all these areas, we should certainly look at it. And the good thing is that MCME also has been recognized as a center of excellence for AI in the Army. So it is for MCME now to take on and come out with some big bang projects of consequence, because that will help establish that flow. Once you can do a good project on an emerging technology, obviously you find that there are many more takers who listen to you, and then your requirements, your demands for future projects will be suitably considered. So that's all I have to say. Thank you.
Thank you very much, sir. And on behalf of our viewers and our subscribers, I would like to thank the panelists for the very interesting discussion, and the points, some very seminal points are there in this, which can be gone through, and it can be culled out of this discussion by existing professionals and decision makers in the field of MRO. And the links to our panelists are there, to their profiles are there in the show notes below. So all the viewers subscribers are welcome to go and have a look at them and contact them for any further queries. With that, I would like to bring this particular panel discussion to a close. Thank you very much. Jai Hind.